Oh, okay. Good morning, good afternoon, wherever you are. Today we're going to be talking about the third lesson in Chapter 10, which is arcs and chords. Nothing really that difficult about this. Couple things that you have to learn before we get started. Let's not forget, in the previous lesson we talked about chords, right? So RS is a chord, right, in this problem right here. Right? RS is a chord and TV is a chord. There's other chords there. But a chord is just a line that connects 2 points on a circle, right? And there's a special chord called the diameter, right? And it's also it's the longest chord that you can draw inside of a circle. So the first one we're going to talk about is the arcs and chords theorem. And this is all it says. Pretty easy. It says if two chords are equal, then their arcs are equal. That's all it's saying. If the chords are equal, the arcs are equal. And also true that if the arcs are equal, then the chords must be equal also. So there's a converse of that statement. So pretty easy. Chords are equal, arcs are equal. So if AB is congruent to CD, so what are we saying in this first picture over here? We're saying this arc is congruent to this arc, right? So the chords must be equal. Then I'll say line CD must be equal to AB, right? And thus 2x plus 3 must be equal to 8x. Do a little bit of algebra, minus 2x, we get 6x equals 3. We get x equals 1/2. Make sure you answer the question. The question is, what's AB? So AB is equal to 8x, right? So AB is equal to 8 times 1/2, which is 4. So the answer is 4. Pretty simple. All right, another one. All right, here we go. This one's a little bit trickier, right? What are we saying? We're saying these chords are equal, so these angles must be equal, right? Angle I said, right? These arcs must be equal. So these arcs must be equal. So if this arc is x, then this arc is x, right? Well, we know that the full circle, right, all the way around a circle is 360 degrees, right? So then we have x plus 64 must equal 360. So we get 2x equals, what is that, 296, I believe? So x must equal, what is that, 145 plus 3, 148? So x is 148. What did I do? Well, once again, if the chords are equal, then the arcs are equal, right? So both arcs were x. So x plus 64. Pretty easy. All right, next problem. Thus, these chords are equal, right? All right, so that means that these arcs are equal. So this arc over here must be 116 degrees. Now, don't forget what we learned in the previous lesson. If the arc and the central angle are equal, so let's back up for a minute, right? If we had a circle up, here, right? And here's an angle, call this angle x, and this arc is also x, right? Because the central angle is equal to the arc that it shares. So that means that the chords are equal, so the arcs are both 116, so x must be 116 degrees because it's the central angle of that arc. Next problem. Looks like we have something missing here. What are we missing? Oh, I see what they're saying. They're saying these are both 4, right? So this is 4 and this is 4. So this chord and this chord are both 4. So if that arc is 82 degrees, then the other arc is 82 degrees. Because if the chords are equal, the angles are equal. The arcs are equal. All right, next one. We're not going to do all these. We'll do a few more. I think we just did one very similar to number 4. 5 is more interesting, right? All right, so what do we know about 5? 5, these arcs are equal. So the chords must be equal. So 2x plus 4 must equal 18. So 2x must equal, what is that, 14, so x is 7. All right? We'll pick another one. Okay, so number 8 is kind of interesting, right? They're telling you these two circles are congruent. So if the circles are congruent, there's an extra little theorem there. It says in a circle this is true, but in congruent circles this is also true. So if two circles are congruent, right, they have the same radius, then the chords can still follow the same rule. So these circles are congruent, so if their arcs are equal, their chords are equal. So thus 6x must equal 2x plus 24. So 4x equals 24, so x is 6. All right. And same thing again. This one's a little bit trickier. So let's talk about this one for a minute. Wait for that to clear up. Okay, so we know this arc is 198 degrees, right? We also know that these circles are congruent. Well, if that arc is 198 degrees, the first question is, well, how big is this arc? Well, that would be 360 minus 198, right? Which is 262, I believe. That sounds about right. Yep, 262. So let's try 162. All right, try 162. This is why I teach geometry and not numbers. All right, 162. So this arc is 162. And notice this arc was 162. The circles are congruent, and their arcs are equal, so their chords are equal. So 9x minus 78 is equal to 3x. So negative 78 is equal to negative 6x. Divide by negative 6, divide by negative 6. What do we get? 13, I believe. So x is 13. All right. On to the next part. All right, so these are, we're going to have to take a little bit of time here. First things first, in a circle, if the diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay, so what are we saying? We're saying if a diameter, so this is the diameter, right? WZ is the diameter. If that bisects, if it's perpendicular to that chord, so right, this is perpendicular. If it's perpendicular to that chord, then it bisects both the chords, so it makes these two halves equal, and it makes these two arcs equal. So all I'm saying on that first one is, if a diameter is perpendicular to a chord, then it cuts the chord in half and it cuts the arc in half. That's what we're saying. All right, second thing. In a circle, the perpendicular bisector is the diameter. It's almost the converse of that statement, right? So if this line is the perpendicular bisector of this chord. So what does perpendicular bisector mean? It cuts the chord in half and it's a right angle, right? So if it's a perpendicular bisector, then it must be the diameter. That's an interesting one, right? So keep that one in mind. It's kind of like the converse of the first statement, right? The first statement said, if the diameter is perpendicular to that chord, then it bisects the chord. So if it's a perpendicular bisector, it must be the diameter. All right, next one. In a circle or congruent circles, right? So this is true in one circle or two circles that are congruent. Two chords are congruent if and only if they're equidistant from the center. Now be careful here. What are we saying? Well, we're saying, so there's the center. Remember, the distance from a point to a line is always at a perpendicular. We learned that much earlier in the year. So what are we saying? If this is equal to this, right? They're the same distance from the center, then these chords are equal, which means these arcs are equal. That's what we're saying. If two chords are equidistant from the center, then they must be equal. All right? All right, so let's look at each one of these and work them all out. All right. If CD is perpendicular to OE, and we know that this line, I'm going to construct it, right? This line would be a diameter, right? There is a line that's a diameter. So look what I just did. It's a diameter. We know that, right? It could be a diameter because it cuts through the center, right? Or a radius, because a radius can just be extended to make a diameter, right? In the circle, if it's a diameter and it's perpendicular, and that's what it says, it's saying they're perpendicular, then what do we know? we know that this arc gets cut in half, right? So we know that CE is equal to ED, right? I don't know if that'll help us with OE. It will in a minute. We'll see it in a minute. All right. So what do we know? We know that CE is equal to ED. All right. So they're going to hide Pythagorean theorem here. So we know that OD is 15, right? So we know OD is 15. That's given. And we know that the whole I'm going to draw this in another color. We know that this chord, right, this blue chord is 24. So ED must be 12 and CE must be 12. So I'm just going to write those here, right? Now I think you can see where we're going with this, right? If those are both 12. Look what's going to happen if I construct both of these, right? Notice what I get. If I blew this picture up, I would have this shape right here. It's a perpendicular, right? This is 12 and this is 15. It's a 3, 4, 5 triangle being dilated, right? So what is that? Oh, I'm sorry, not a 3, 4, 5. It's sorry. Oh, this is 15, not 13. No wonder. Yeah, I thought it was a 3, 4, 5, right? So it's a 12 something 15 triangle, right? Divide them both by 3, right? What do we get? 4 and 5. So this is the 3 times 3. So it's in the 9, 12, 15. So what do I know? I know that OE, right? This right here must be 9. And that answers the question, right? The question is find OE. OE must be 9. So once again, let the theorem help you to figure out what's missing. There's going to usually be a Pythagorean theorem somewhere in there. All right, next problem, example 4. In circle O, let me make sure I'm still recording here. Yep. Excuse me. In circle O, circle P, the radius is 13. Okay, so I'm going to draw that. I know that from here to here is 13, but check this out. I also know that from here and here is also 13. I'm just drawing these. I'm not sure if it'll help me or not. I also know that RS is 24, and I know that this is a right angle, right? So that establishes that line is a diameter, right? QP is a diameter, and it's perpendicular, so it bisects it. So I know that this is equal to this. And if RS is 24, then if I blew this up, this would be 12 and 12, right? So could I find this? Could I find this? I'm going to change my pin size. I'm going to blow this up now, right? I'm going to bring this out over here. I would have this triangle. It does not look like it's to scale, but that's okay, right? This is, oh, it probably is to scale because this is not a 3, 4, 5. All right, I've got a right triangle there. So this is 5, 5, 12, 13. Now I'm going to kind of erase a lot of this and rewrite it for us. All right, what do I know? I know that this is 13. I know that this was 12. And I know that this was 5. But look what the question is. I don't know. Oh, let me make sure I'm answering the question. What's RT? RT was given, right? It's 24. All right. PT. PT, we just figured out, right? PT was 5. All right. And then here is where most people would get stuck. They'd ask, well, how do I figure out what this is? That's what TQ is. Be careful. They're hiding information from you. What do I know about QP? I know that QP is a radius. Oh, so it's also 13. So QP must be 13. So see what I'm doing here. I'm going to draw this in red, right? From here to here, right? That line right there is 13. So if the whole line's 13 and that TP is 5, then TQ must be 8. So they're going to hide information from you. Be careful with that, all right? All right, let's do another one. What do we know? CD is 8. Notice this is a diameter and it bisects it. So I now know that CF is 8 and FD is 8. What else do I know? I know that CD is 90. I know that this is 90. So I also know that this is 45. And I also know this is 45, because don't forget, it bisects the chord and it also bisects the arc. All right, so let's see if we can figure out some of these now. Do we know DE? Yes, because CD was the chord that got bisected, right? We know it's going to bisect it. And it also bisects the arc. The whole arc is 90, so DE is 45 degrees, right? FD is 8. That's easy. Now we're going to get to the hard part, AF. All right, so once again, we're going to have to look for Pythagorean theorems here. Do I know the radius? No, I know the diameter is 12, so I know the radius is 6. Now watch what I'm going to do here. I'm going to draw this a lot bigger now. I know that the diameter was 12, so the radius is 6. So this is 6, and this is 6. And what do we know about CD? CD was 8, so these are 4, right? So this is 4, and this is 4. All right, what am I looking for? AF. I'm looking for this right here. Well, let's just blow it up. There's a triangle there, isn't there? Just like this. This is X. We don't know it. This is 4, and this is 6. We got a triangle here, right? I don't know any triangle that does that, so I'm just going to have to do the math for it, right? X squared plus 4 squared equals 6 squared. So what do we get? X squared equals, let's see, bring the 6, that's 36 minus 16. That's 20. So x squared is 20, so x is root 20. And do your math for that. That's going to be 2 root 5. I'm not going to tell you how to do that. You should be good at that by now. So AF is 2 root 5. Pretty cool. Just use Pythagorean theorem once again. All right, next problem. Example 7. TS, chord is 21, right? So this is 21, all right? UV is 3x. Okay, now check this out. Let's go all the way back up here. Read this. In a circle, or congruent circles, two chords are congruent if and only if they're equidistant from the center. Well, what do I know? Look, here's the center, and they're both distance of 6 because they're at right angles, so that's the shortest distance. They're both 6. What does that mean? That the chords are equal. Oh, this is easy then. If TS, so TS must be equal to UV, and TS is 21, so UV must be 3x. So then x equals 7. Done. Easy. Next problem. CD is congruent to CB. All right, so I know that this chord is equal to this chord, right? Thus also this arc is equal to this arc. I don't know if that'll help me. All right, GQ is x plus 5, and EQ is 3x minus 6. Well, notice, right? If these chords are equal, then they must be equidistant from the center. So these must be equal. Oh, then that makes what? That makes GQ equal to QE, and that makes x plus 5 equal to 3x minus 6. So 2x equals 11. Let's fix that. It's pretty bad. 2x equals 11, so x is 11 halves. And that's it. All right. Going back, let's do a little recap. If the chords are equal, then the arcs are equal in a circle. Second thing, if a line is a diameter and it's perpendicular to a chord, then it bisects that chord, right? And then the last one, two chords are congruent if and only if they're equal distance from the center. All right, well, go ahead and work on this. If you need help with it, send me an email, send me a comment on my YouTube channel, and I'll be more than happy to help you. All right, good luck with this. Take care.